Hey guys, welcome back. Mr. Monroe's Math here, lesson 12 from Module 4 about algebraic expressions, and we're really focusing in from the last lesson. And what we're trying to do is write an expression that is equivalent to two groups of A plus B. So what do we do for a model? We have one group of A and a group of B. That's how we represent for one model. All right, so the expression 2AB tells us that we have two of the A and B's, so now show two groups of those. So where we had one group before, okay, very similar here, we just simply add on a second group. Okay, so now there's two. And it's showing here, this is A plus B, and here as well, an A plus B. So how many A's are there? There are two A's. And how many B's? There are two B's. Continuing on, all right, you can group these together, but we can also find different values for them. Let's say that A equals 3 and B equals 4. Okay, so what expressions would be written? Well, I would have a 2 in parentheses A plus B, because there are two groups of those, and that's equivalent to 2A plus 2B. And we've talked about how it distributes in before. This is a very old school method of multiplying in relating to what we're doing now. So what can we conclude? They're going to be equivalent expressions. Let's find out. Let's say A equals 3, B equals 4. And let's substitute them in. So I'm going to do 2 times the value of 3 plus 4. And this is not addition, okay, so we're not combining the two. We're going to say 2 times 3 plus 2 times 4. All right, so getting to that, let's simplify. Order of operations, it's going to be 7 times the 2, and we should get 14. Okay, so let's check this. This is 6 plus the value of 8, and that sum. Oop, not 18. I saw the 8. Sorry, 14. We should get the same thing. Okay, so what happens when we double A and B? It's two groups of 7. And it becomes 2 times the sum of A and B. Okay? For example 2, let's get there quick. Example 2, we want our highlighter out. We know that this one is important. We want to focus with example 2. Now with example 2, write an expression that is equivalent to double 3x plus 4y. So if that's one of them right there, and we want to double it, it's simply multiply 2. 3x plus 4y. Okay, so all we're doing is doubling that right here. Two groups of that. Okay? Is this in factored form, expanded form, or neither? Okay, well this one right here is in factored form because we have a GCF, and that GCF is 2. Okay? Standard form would be if we distributed this in. So standard form would be, well, 2 times 3x, which would be 6x, plus, so two terms, 2 times 4y would be 8y. So that would be standard form. Okay? Let's turn the page. I'm going to skip that modeling for now because you've already got that idea, but here is the crucial point. Okay, right here, example 3. And this is definitely going to be on the test too, so make sure that you understand this part here. All right, so if I have this model, right, and I have an expression in expanded form equivalent to the model below, okay, expanded form would show that I have this value of y is also right there too. Okay, it's that length. So basically we're finding the area of each rectangle here. So we would have 4x times y plus 5 times y. So each term shares the y value. Okay, so be knowledgeable of that. So what factored expression is represented in the model here? Well, they share that y, so y would be outside the parentheses, and then what's left is that length right there. So very similar to finding area, a length times a width, and we would also have a 4x plus 5. So that's our factored form right there. Okay? Can we rewrite this expression in expanded form? Well, yes, we can. It's very similar to here. Okay, we have 4x and y, and of course with letters next to each other are variables, it means multiplication. Okay, so that's the first term, and then the second term, see first term here, and then we can do second term here. Okay, and then second term would be 5y. Okay, 5y. All right, so copy that down, give you a quick break. Okay, so there's that model right here. How can we change the model to show that two groups? Well, we have one group of 3x plus 4y, and then a second group of 3x plus 4y. And we know it's addition because they're combined together. Notice we are not breaking them apart and doing this. We don't want to do that. We want to keep them all combined and together. So let's turn the page. Let's get more to this, okay? So for these exercises, we want to create a model for each expression below. Okay, so for these ones, we're creating models. On the next page, we are not creating models, we are simplifying them there. So this looks like it would be a lot, but we are not doing models for these ones, okay? But let's get the idea. And the models is very much this idea for Eureka Math, the Common Core idea, showing and explaining why these situations work, okay? So in my day and in your parents' day, we didn't necessarily so much model these as much as what you are doing. So we are taking it a step further now from before. So let's create a model for each expression below and then write another equivalent expression using the distributive property. Okay? Now what we used to do is simply just go like this and multiply out. Okay? And multiply it in. And to write another equivalent expression using the distributive property, what we would get is 3x plus 3y. That 3 is the GCF. It is the common factor for both of the terms. There are two terms here. Because there are two terms, we have to have 1 and 2. All right, so with that in mind, let's show the model. So we can have an x and a y, an x and a y. It's very repetitive sometimes, an x and a y. And there are three groups of these. Okay, the x plus y. Another thing we could do to show more of this one here, okay, is to show 3 of the x's. So distributing this in, this idea here would work with when we have all 3 x's next to each other. And then all 3 y's. And notice my displays are very similar in length. A little bit longer because they're just a little bit off, but I'm showing the difference between the two. So here's my 3x, okay, so my 3x plus my 3y right here. Okay? Let's do another one. 4 times the value of 2h and g. So I have 4 groups of 2h plus g. So one of my groups can be 2h and g. And then I could have 4 of those. So I could do a second, a third, a fourth. Okay? An equivalent. All right, so we are now going back to the old school idea. Okay? Kick it old school, 8h plus, and we multiply in, so 4 times g. So again, two terms, it's 4g. Okay, the factor here, greatest common factor, is 4. Between the 8 and the 4, we took that out and got that value right there. Excuse me, so right there. Okay? All right, couple quick examples. Okay, go over the exercises, because tonight you're going to do the other side, the problem set, which is right there. Okay, but on these exercises, we'll see number 3. So apply the distributive property to write equivalent expressions in expanded form. All right, so expanded form, we're simply expanding that out. Okay, so we're going to have multiply in 8h plus 24. Okay, and I think you get the idea of what we would do after that, where we get to multiple values. So hold on one second. All right, let's get back to it. So we have these exercises. We're looking at number 3, and the expanded form here is 8h plus 24. Now, I guess you could expand that further, but this is the simplest form of expanded form. Now, we would multiply the 3 in with each of these terms, so 3 times 2h, so we could show 3 times 2h plus 3 times 7. We can simplify that. We have 3 times 2h giving us 6h plus that favorite number, 21. Okay, so for this one, 15x, and I'm doing that because 5 times 3x shows 15, and multiply the x, plus 5 times 9y. Okay, remember, keep the variables where they are situated. All right, and that's 45y. Notice I'm not putting this term before. Okay, also alphabetically helps with the variables, but also where they are set, it's just going to make it easier going forward in the future years. Okay, and one more using the one more using the model idea. This j with a 7k and the 12m. Okay, this j is also on this side as well here, and looking with that area, very much the area with the length times width idea. Okay, so we have that. So what I'm doing is multiplying 7k times j and 12m times j. And I'm going to shrink that up. And I'm going to put these alphabetically as well. It's the same as this, and it's equal to 7jk plus 12jm. Notice what the factor is here in common. 12 and 7, we can't find a common factor. However, the j's we can take out, and we get back to this value here. Okay, so problem set is yours. Get this done tonight. Good luck, and we will see you tomorrow in class. Smash that like.